Hello everyone, it's 29 January. January is almost done, and another lead code video. Today I'm starting with, I'd like to start with easy problems to kind of give you that initial confidence. Add binary. Add binary. Given two binary strings A and B, return their sum as a binary string. Okay. Let's say math string bit manipulation simulation. So it's a string of zeros and ones. Each string does not contain leading zeros except for zero itself. It's quite interesting. I have solved this problem, but I don't remember it. Okay. So 1 is 0 and taking the carryover 1 so it's 0 again. So 1 0 0, that is 4. 3 plus 1 4. How? Let me just do this. 10 minutes. I'm gonna put a timer for 10 minutes because it's an easy problem. We should be able to. We are expected to solve an easy problem in 10 minutes in an interview. Okay. Thinking. It's a string. So that means maybe I just need to simulate this problem. Yes. For example, let's take this input. For example, it's copy. So it's 0 0 1 0 1. I mean, sorry, and then 1 1 is greater than 1. So taking the carryover. Yeah, let's just try to simulate it. Normal. But both strings can be of a different length. Yes. for character ch in string to character array. Let's just have a pointer. Index, I don't know, can I do this? A index 1 is length minus 1, index 2 is b's length minus 1, while index A is greater than minus 1, and while index 2 is greater than minus 1. Yes, of course we'll have some we'll have so let's say and 1 is charAt index 1, and just do we need to do this step? Let's just try. And 2 is charAt index 2, and this, right, let's carry false. Let's try to add them now. If n plus 2, and I need a answer in the form of a string, right? So string builder, space new string builder. So if n plus, if it's greater than 1 1, if it's greater than 1, then I'm gonna have to carry that value over. So carrying is true. Well, let's just keep it to 0 and set this to 1. Okay, and zero plus 1 is not greater than 1, so we are simply setting my string to 1. Answer dot append answer dot append 1 1 1 and 1 is 2, so carrying over the value. If that's not the case, then answer dot append in result is n1 plus n2. If result is greater than 1, carry. Return sp2 string, and let me just look at the content. Very basic version. I don't expect it to work. sp of need to my index is x2 x1. We can have leftover values if the height of the strings are different. Output is 1. Why? Yes, like I said, we can have leftover values. Is 1 is 1, and just after running for one time, loop exhausted. So I can just say if index 1 is greater than -1, then let's have this in else one is 0 and 2 is 0. Same, you can do the same thing with the second index. If it's greater than 1, index 2, right, don't need this. carry plus 1. If result is greater than 1, then append 1 and set my carry to set my carry on, else just append the result. What else can I do? Last, if carry is 1, speed dot append 1. Let's check. So 1 and 1 should have been okay. We started it from the last index 0 0 1 0 is 1. System dot out dot print sp. Okay, so the result of this calculation is 0 for some reason. Why? So I'll do second calculation 1 1 1 plus 1. What does that mean? Is 1 1 2, and because it's 2 we are adding 1 only, and this is that 1. Yes, I need to reverse the string, and then 1 0. Why the result is 2 again? Maybe the carry thing is not working fine. Why is it 0? Why is it 2 again? Yes, that's why. 0 1, but for some reason uh, I thought it was an easy problem. 1 1 1 and 1 2, so but we had 1 and then 1 0, still 2. This is wrong, this is wrong, this is very wrong. 2 because 1 1 2 because of the carry. Oh yeah, there is also carry. Okay, then it's 2, which is, it's still greater than 2. What's happening here? 0 0 0 1 is 1, 0 1 is 1, and 1 goes to my string builder. 1 1 is 2, but only 1 goes into my string builder. Should have been 0. Whenever isn't 1 1 1. I'm doing this right. I'm doing this right, right? 0 0 is 1. 1 1 1 1 is oh, it's 2. It's 0, I mean, because the 1 gets carried over, so it's 0. Now it's 1. Okay, and it's 0 again. Let's see now. Yeah, but it just need to, I think, reverse this. Yeah, just need to reverse the to reverse. Oh, there is no such method, really? String builder reverse. Yep. Please. Okay, this is really the most extreme case. Okay, but we have our log right here. So 1 is 2, but 0 goes into my singulars. 1 gets carried over. 1 It's 3 this time. 3 is what? 3 is 1. Okay. You know what? I think 3. I need to convert its base. How can I do that? It's a base 10 integer. I need to turn it to base 2 integer. Else I'll keep getting these. Maybe divide it. Is that back? That's 1 into 1.5. No. 30 minutes. This should be hard. Like I should know how to convert how to change bases of numbers. If it's 2, then 0 goes to my. If it's 3, 1 goes into my. If it's what's happening here? If it's 4, I'm not sure. Let's try. Okay. I don't have problem. Fleco don't have problem. Some carry. Okay, some is carry. Doing the same thing here. Of course. Of course. I knew this. Man, I'm so. base 2, base 2. This is so neat. Okay, even though my solution I've just tried some pretty weird cases and it works, but this solution is very neat. Okay, good problem, good problem. Next problem, time-based key value store. Design a time-based key value data structure that can store multiple values for same key at different timestamps and retrieve the key value at a certain timestamp. Time map initializes the object of the data structure. Void set store just okay. Void set stores the key with value at the given time. Get returns a value such that set was previously called with timestamp. If there are multiple such values, it returns the value associated with largest timestamp. So it's like designing a hash map, but with the ability to retrieve keys or value at a certain timestamp. Alright, let's look at the example. Foo key bar timestamp is 1 and they'll give us a key and a timestamp and we should return the bar. Okay, there is no 3. We don't have any value stored at 3 timestamp, so we're just gonna give them, since there is no value corresponding to foo at timestamp 3 and timestamp 2, then the only value is at timestamp. Okay, if they give us a little larger, little higher timestamp and we don't have that, so we just return the one we have, the value for the one we have. Set foo bar 2 store the key foo and value bar 2 along the time at 4 at 5. Okay, but what if they give us a okay, so this foo bar 2 is stored at 4th timestamp. What if they ask for foo at 3rd timestamp and there is no smaller value, there is no foo at 2nd timestamp or at 1st timestamp, so we don't give them anything, right? Maybe, let's see. So it's just a basic hash map problem, and it's basic in a sense, in a sense that we just need a hash map, key hash map, string is my key, and I can just define my custom class around node. It well, it needs to be a list. A list of what? Well, with list, I can So my plan is just to populate the entire this string list strings list of strings with empty strings along the line, right? So for example, if you're asked to set foo bar2 at 4th timestamp, and suppose my string is empty, there is no object in this list, there is no string in this object. So what I can do is I can do something like this. At 4th index, I can add bar2. Just gonna make sure that I don't write any previous values if they exist. What is the default value? What is the default value of a string in Java? Values dot add. Okay. Let's see. I want to look at my string. Let's inspect this object. Map. Return. Index. Yeah, sure, there's no object in that. I can do this. This is not an array. So yeah, I really need a custom data object to store my timestamp. It's gonna be of type int, and my value it's a list of data objects. We don't need this. New data. Well, I don't need to worry about the sequence, the order, the order of the timestamp. Whether it's in whether it will be in, like, they can't they can't give me, yeah, this is all the timestamps are strictly increasing, because otherwise it would not make any sense. Sure, but okay, but I could do. timestamp. I don't have a constructor. So data dot value is value. Data dot timestamp is timestamp. Okay. Wait. Don't need this. Don't need this. Array list. It's still an array list. Now I'm really getting confused here. Map.get no, map.get key add data. Have we got it? Yeah, it looks like we have. Getting the data is the trickiest part. Okay, well. I needed some water. Okay. Like I said, getting the string is the trickiest part. Let's first of all get the list data values is a map.get key. Okay, and now I want the value at a certain timestamp. I gotta do binary search here. Starting from 0 to get here, while start is smaller than end, and mid is going to be start plus end divided by 2. So I can say if values dot get mid dot timestamp int data is values dot get mid data dot timestamp is if it's it should not be smaller. String answer if it's greater than the timestamp we need, the timestamp they are looking for, then we need to look more to the left. But there is a possibility that there may not be any value at that timestamp. So this could be the no. If my timestamp is greater than the timestamp they are asking for, then no. Then I went a little high. I need to lower myself. Then I need to lower myself. I need to do and is equal to mid minus 1. Else if data dot timestamp is smaller than the timestamp they asked for. Okay. Then I need to start looking up. +1. Else just return data dot timestamp, no, data dot value and answer. Maybe there may be a chance if my data stamp, let's update the value of answer here. Dot value, because if I find the answer at 1, no, because if I find the answer at 1, then I can just store the value because we may not have the data, we may not have any value at the timestamp they are asking for. This is size. the size of the list is 1. So what is the value of mid at that point? Mid 0 plus 1, 0 is 0. They asked for value at the third timestamp, but there is only one element, so my data was smaller. My timestamp was smaller, so dot value, if my timestamp was greater, love high at timestamp 10, love low at timestamp 20. Okay, so these are the two values for love key. 5 low. Set high get love at 5th index. We don't have anything. No, we don't have anything at that timestamp. So if we don't have anything at that timestamp or at any lower timestamp, since the size of the list is only 2, so it's 2 is 1. 0 1. In this case, my timestamp is smaller than okay, it gave the right value. It gave okay. For next get, it gave no, it the right value here. For next, now they're asking for low. They're asking for love at 10th. At 10th live, and we don't have high. Set get set get love, value of love at 5th timestamp. We only have value of love at 20th timestamp, so we don't return anything. Then they're asking for value of love at 10th timestamp. We still don't have anything, so we should have returned. Actually, my loop should have been ended. For some reason, hi, am I doing and minus start? At this point, my loop should have had ended. What am I doing wrong? Mid. Stays 1 1 1 1. Looks like I may have to do this thing. Yes. This is a problem. My timestamp is lower. Wait, what is the data dot time value at data dot timestamp. Low at 20. Yes. Low at 20. There are only two. 20. Data my times it's 20. So my timestamp is 20, and they want at love high at 10, love low at 20, love 5, high. Okay, yes, it should have been high. Makes sense. What am I doing? Like, what am I storing in my list? Low at 20, love low at 20, 10, 10, 10, 10, 10, 10, look, 20. If my times 10 is greater than theirs, right? So end is equal to mid minus 1. It's a problem with binary search. This binary search is wrong. I'm feeling like it's wrong. Because the right value is at 0th index in my string of in my array of strings. But we never get to that string. To so 1 1 minus 0. Okay, divide by 2. So it's 0 1 0 1. So it's gotta check if my list is if values is null, then return an answer. Okay. I've finally got it submitted. Just to keep tweaking with your binary search until it works. That has been my trick tool, guiding principle. Okay, what is the time and space complexity? Interesting to see that in this question. Time complexity, no, space complexity. Let's talk about space complexity first. Space complexity, I am using a hash map. Using a hash map and this list of data, and it's linear. Space complexity is linear. The size of my hash map depends on the size of my input on my keys. And in my get function, am I defining any extra space? Nope. Nope. Nope, not really. So yeah, the space complexity is linear. Time complexity is first of all, I'm using a binary search. So what's a binary search? Login and login, or login, and yeah, I don't think there is anything extra here. Let's verify. Login, time complexity, space complexity is not linear. Space complexity is not constant. Well, it can be constant because we are literally asked to design a data structure. So let's just confirm ChatGPT plus. Okay. Explain me the space and time complexity of this problem in a few words. According to me, both space complexity and time complexity are linear. But time is no, I mean, okay, yeah, sure. Space linear, time complexity is log n. Yeah, that's it. We're done for today. Thank you for watching this video. Well, no. Let me look at my previous submissions first. Or you can define a constructor in your data class if you want to get fancy. If it doesn't contain that key, return immediately. Key timestamp. Yeah, see, there is this. It's always. I'm never sure about binary search. Like, should I do it this way, or should I do it this way? I feel this way is simple. It's more simpler than this. in this one I'm doing extra things at the end. Here I basically find the answer within the loop itself. So yeah, there are some differences. Now this is some different approach. It's same like the previous. Okay, I'll probably need to look into it, and I'll look into this problem more deeply when I would only focus on the binary part of this binary search part of this problem when I will get to binary search problems. Okay, yep, that was it. Thank you for watching this video.